Afternoon, class.
Afternoon, sir.
How you doing?
We are fine, thanks. How are you, sir?
I'm all right. Today we'll talk about a transistor. There are many types of transistors. The one we'll be talking about today is a bipolar junction transistor, also known as, in short, as a BJT. A bipolar junction transistor is a three-terminal semiconductor device that is used as a switch or an amplifier. A bipolar junction transistor is formed by three layers of semiconductor material, like this. Together, these three layers, they generate a junction known as a PN junction. This is the interior, the inside of the transistor. We have two types of transistors. We have a this is the symbol of a transistor. If you see this drawing in a circuit diagram, you must know this is a transistor. We have an NPN, NPN, and we have a PNP. These are the two types of transistor. How do you know that this one is an NPN and that one is a PNP? By means of an arrow. There's a small arrow in the emitter terminal. In a NPN, the arrow is pointing outwards. In a PNP, the arrow is pointing inwards. You see the difference? Yes. This is the PNP, this is an NPN. These terminals are called collector, base, emitter. This one is called emitter, base, collector. You see, if this interior part, let's say for instance, was a PNP transistor, therefore this part will be a P, this one will be a N, and this one will be a P. So it's an emitter, base, and a collector. Can you see that?
Yes, sir.
Now, there are a lot of questions now. Okay, and the junction. These are the junctions. This one will be J1. This one will be J2. They call them the PN junction because they're in the middle of this semiconductor material. The P come from this P and the N come from this N. That's why it's called the PN junction. PN junction. This P stands for positive and the N stands for negative. In this case, this terminal, let me assume it's an emitter. It is positive, or it is filled with holes. But here there are electrons in there, closer to the junction. So and there are holes here. But it's filled with electrons or negative charge carriers. Here are holes as well. But here there are electrons along the junction. This will be the base. This will be the collector. The base is always the thin one because it's lightly doped. The emitter is heavily doped, it's a big one. And the collector is also big. In a symbol, you see the emitter by means of an arrow. Is an emitter, and the base is always this one. The other one is obviously a collector. It doesn't matter how did they draw it. The one with an arrow is always an emitter. But now there are questions. The first question is, let me just write why. Why is it called a BJT? These three terminals why that other one is called a collector, why base, why emitter. So now let me redraw this interior of the transistor so that you can answer all these questions now. This is the emitter, the base, this is the collector. Let me just put this on there. Let's just assume that this is a PNP, ne? PNP, the base. We put a resistor here to limit current. Then let me put a supply voltage here. I'll call the supply voltage VEE. So it is a reverse bias. I'll call this one VCC. Can you see that? This is junction number 1, J1, junction number 2, J2. This one is filled with holes, ne? I'll just draw roughly. But here on the junction, there are electrons. Here there are holes, but it's filled with electrons, ne? Or negative charge carriers. And then the rest is filled with holes, ne? This first junction is also known as emitter. Yeah, let me not write it down. But it's also known as emitter base junction. This junction is also known as collector base junction, because this is the collector, this is the base, and this is the emitter. You see? So now to answer these questions, if this one is forward biased, it will generate a current here. Let's denote it as IE, since it's the emitter current. So it denote it as IE. These holes, this positive charge of the battery will force the holes to diffuse through the emitter base junction, because it is forward biased. So it will force the holes to flow through this junction. Let me use a different color. Use green. It will force the holes to diffuse through this junction, creating the current. We can call this current IPE. The P is for positive and the E is for the emitter. The I represent the current. The current is denoted by I. So now we have IPE. Do you understand?
Yes, okay.
So it will flow in this direction. And then here, once the holes get this side, they will fuse together with some of the electrons on this side, because the electrons that were floating here, but they didn't have much energy to move. Ne? So since there's a cell here, they will fuse together again. But most of the holes will fuse again through this junction, which is a collector base junction. But now, as you can see, that already the emitter have a purpose. Ne? Its purpose is to emit the charge carriers. The holes are also known as charge carriers. It emits the holes from the emitter through the base to the collector. That is why it is called an emitter, because it emits the charge carriers. In this case, since this is a PNP, the large carrier on the emitter side is positive, or also known as holes. If it was the NPN, it was going to be the electrons, or negative. Does it make sense?
Yes, sir.
So this current that fused through to the collector material, we can call it IPC, because it's a collector current. Here from the base to the collector, there will be another current that will fuse through this junction, which is a collector base junction. Remember now that the collector base junction is reverse biased, so there will be a leakage current from the emitter to the collector. We call it current ICO, because it's a leakage current. But now we're not done yet. The base is also known as a control terminal, because none of this will happen until there's a small voltage we are dealing with the PNP mostly. So this is the emitter, the collector, this is the base. For the transistor to conduct, first we need to inject a small voltage here. We call it VBE, the voltage between the base and an emitter, between these two. Since it's the P and P, this would be negative. Here it is, it's negative. So this voltage must at least be approximately 0.7 volt. This transistor won't start conducting until this base receives this amount of voltage. So we call it a control terminal, because it controls the switching of the transistor, whether on or off. If we inject this, depending on the configuration, a small current through the base, that small current will determine how much current will flow between the collector and an emitter. Hence, the base is also called the control terminal, because it controls the operation of the transistor. We've answered that. Now the collector. Why is it called the collector? All the charge or the current, or let's say the charge carrier from the emitter, is collected by the collector terminal. It will flow through now to this side again. Oh, I forgot to put a resistor here to limit the current. There will be a resistor on this side. So the collector is called the collector because it collects the charge carriers from the emitter through the base to the collector. Hence it is called the collector. Do you understand?
Yes, sir.
So now let us put together all the current that are generated through this emitter. IPE is a current that is produced when the positive charge carriers are diffused through the PN junction or the base emitter junction. We also have another one that is generated when the negative charge carriers are diffused from the base to the emitter and they fuse with the positive charge carriers. We call it INE. N is for negative and E is for the emitter current, and then I is for the current. So the current, or IE, or emitter current, we can write it as IE is equal to IPE plus INE. But now the negative charge carriers are so small that they don't make any difference in this. So we can write it, you can write IE, which is the emitter current, to be approximately equal to IPE. Does it make sense?
Yes, sir.
And then on this side, the fraction of the diffused positive charge carriers from the emitter through the base to the collector are known as alpha, or are denoted by alpha. Does it make sense?
Yes.
So now we're looking at the current, or the collector current. So basically the collector current is equal to alpha multiplied by IE, which is the emitter current, plus this reverse current that is denoted by ICO. Does it make sense? Let's find alpha. If we transpose this one, we make alpha the subject of the formula. Alpha is equal to IC minus ICO, which is the leakage current, all over IE. That is alpha. It forms this current here, which is the collector current. You see it here, mostly. Alpha is also known as a common base current gain. Ne? There's another current gain that we use to determine the amount of that large current that flows between the emitter and the collector, and we call it beta. Beta is equal to the collector current over the base current. You get beta on a data sheet name. Beta normally ranges from 20 to 300. Let's say you want to amplify the output current from the transistor. We get our output here. The small base current that you put in here will determine how much current you're going to get outside using this formula. Let's assume that beta is equal to 200. Ne? Let's say we got it from the data sheet. And we inject in this transistor, we inject 1 milliamps. Ne? To find out how much current you're going to get, you use this formula. You say 200 for beta is equal to IC. IC will be the collector current all over 1 milliamps. And then you cross multiply on both sides by 1 milliamps. 1 milliamps. You know this one already would cancel. Therefore, IC is equal to 200 milliamps. That's how the collector amplifies the current. Ne? This BJT transistor is also known as a current controlled transistor, because if you put a small amount of current, which is 1 milliamps, you get 200 milliamps. Beta is also known as a common emitter current gain. Ne? But now we have one question that we haven't answered yet, and this is the question: why is it called a BJT? You saw that in a PNP. Now just use one color. This is the PNP. In a PNP, the emitter emitted positive charge carriers through the base to the collector. So in this case, the positive charges were taken as a positive charge carriers in the NPN and NPN. The emitter, but in this case it will emit the charges on this direction. It's not the same for the PNP and the NPN. It will emit the charges in this direction. But now the charge carriers will be negative instead of being positive, since this emitter terminal is negative. So for that reason, they call it a bipolar junction transistor. They say bipolar. This bipolar indicates that this type of a transistor uses both positive and negative charge carriers to carry charges. Bi means two. Polar means both negative and positive. Junction. They talk about this junction, which is the emitter base junction and the collector base junction. But in this case, we just call it J1 and J2. We answered the bipolar, we answered the junction. What about the transistor? Why is it called a transistor? The word transistor came from the diffusion of two words, which is transfer plus resistor. The trans come from here, the star come from here. Okay, the I must be on this side. Transistor. Basically, a transistor is a transfer resistor. Why do they call it a transfer resistor? If you take a look at this, the internal part of the transistor, this one I'm gonna make it a little bit larger than that one. Take a PNP. If you have a look at this junction, this is VEE, this is VCC. This junction, J1 is forward bias, so the junction is narrow. This is J2 as compared to J2, because J2 is reverse biased. If the junction is forward biased, the junction tends to be very narrow, making its resistance be more or less zero in the ideal world. But in a real world, it is very small. If the junction is wide, the resistor is very big. In an ideal world, we say it's infinite, so the resistance is very, very big. But in a real world, we just say it's very big. So if you send a signal through the emitter, through the base to the collector, you see that we've transferred the signal from the small resistor or the small resistance, which is from this junction. When the charge carriers go through this, they face some resistance here. That's why we say it's similar to a resistor. So they face some resistance. So they go through from the P-type material, which is the emitter, to the base, from the base to the collector. So you've transferred this signal from a very less resistor or low resistance through the larger resistance to the collector. So you've transferred this signal through this resistor. So instead of saying this is a transferring resistor, we just say it's a transistor. That's where the T comes from. Now we've answered all the questions now. So a transistor is a transferring resistor. Does it make sense?
Yes.
Why is it called a BJT? The bi is for bipolar, because it uses two charge carriers, which are negative and positive. junction, we get the two junctions when we mix the three terminal semiconductors. What are they? Emitter, base, collector. So what are the names of the two junctions? The PN junction. It's a base collector. No, not emitter, base. You want to see the sketch? This is the emitter, this is the base, this is the collector. What do you call this one? Base emitter junction. This one. And this one is a
Collector.
We can say base collector or collector base junction. That's a J4. The transistor will transfer a signal from the less resistance through the base to the larger resistance and then through the collector. That's why they call it a transistor. Why is it called a collector, this one? Because it collects the charge carriers that are emitted by the emitter through the base to the collector. The base is also known as a control terminal because it controls the switching on and off of the transistor, also the amount of signal that is going to be amplified. Remember that if we inject 1 milliamps through the base, we might get 200 milliamps on a collector. So the base control the operation of a transistor. And the emitter, what does the emitter do? It emits the charge carriers. Now, how do we know? Before the know part. What type of a transistor is this? Is it a PNP or NPN, and why? Yes?
NPN.
Why NPN?
That's outside.
Because the arrow is pointing?
Outside.
So, not pointing inside. Is that how we remember it? How do you remember this is an NPN? Not pointing inwards or not pointing inside. What do we call this terminal? What do you call this terminal? Okay, what do you call this one? The easy one. Yes?
Emitter.
You call it an emitter. How do you know it's an emitter? Because there's an arrow in it. The arrow is pointing outwards, meaning it's a...
NP.
And then this one is a... Yes?
Base.
This is the base. This one is obvious now.
Collector.
It's the collector. Another type of a transistor, there are two most. There's an NPN and the other one. Yes?
PNP.
PNP, that's it. Let me draw it this one. Let me draw it here. Now I want you to tell me now. Where must I put the arrow and where must it face? Must I put the arrow here?
No.
Here?
No.
Here?
Yes.
Where must it face?
This side.
This side.
Yes.
And then what do you call this terminal?
Emitter.
Emitter. This one?
Base.
Base. This one?
Collector.
Collector. Now, since, okay, this one is a PNP. This one is widely used as compared to this one, the NPN. Now, to power this, I didn't teach you this one, so I'll just tell you. Now, to activate this, you need to supply the base emitter with a positive supply. It must at least be greater than this VBE. Must be equal or greater than 0.7 volt. It must be positive because it's an NPN. This positive terminal of the battery must forward bias this, so it must be able to push these charges through the emitter to the collector. Does it make sense?
Yes.
That is all for today. The next time we meet, we'll talk about how do you configure the transistor. Ne? We have a common base. This one is common, known as common emitter. You have the common base, common emitter, and a common collector. We'll know why is it called a common collector, common emitter, common base, and what is it used for. We'll also know the modes of the transistor, the operating modes. We have an active mode, saturation mode, and a cutoff mode. Ne? The class is adjourned. Peace.